Now therefore K FD times V will be the power to overcome this air resistance, which is KV squared. You like? No.
So wait. So what's the context?
The context is something that is orbiting around the Earth such that it encounters atmospheric friction. Yeah? So it goes through atmospheric friction, and then when it goes through atmosphere, it starts to slow down. Then when it slows down, it starts to go down.
Okay.
Right? Eventually, we're going to get an expression for the time it takes for the satellite to crash. So okay, then power equals to F times V. I hope you know how to derive that. That's topic 2, long time ago.
Okay, yeah, sure.
No, just 8 topics ago. Just 8 topics ago. Okay, so this is power equals to kV squared and power times dt. Equals to minus dE. Why minus? Because it loses energy, right? So dE equals to P dt, which is equals to minus kV squared dt. You okay? Yeah. Now remember your orbital speed. V equals to root gm upon r. So therefore, kV squared will give you a rather nice equation, which is gm. Before? Okay, good. Now you should be able to by now quote this expression. Total energy is equal to K plus P, and if you sum them up, P plus KD, you're going to get this expression. Therefore, E is equals to minus GMM upon 2R. If I go for dE dR, what is it going to be? What is it going to be? Come on! Simple differentiation.
Log R.
Log R.
Wait. No. I'm so sorry.
Hey, not integration, relax. Differentiation.
Wait. Sorry. MCTs.
Integral of 1 over R is gone. Yeah, so it's going to be GMM upon 2R squared. Why does the negative sign goes away?
-1.
Because minus 1. Yes, right. You bring down power, bring up power minus 1. That's the mantra, right? Power bring up power minus 1. Therefore, dE is equals to GMM upon 2R squared dR. So therefore, if you put dE into there, GMM upon 2R squared dR is going to be equals to K GM upon R dt. And you can do quite a bit of cancellation. So dr upon R is equals to 2K upon M dt. Now here comes the law. Here comes the law. You said the correct answer.
Saw this coming.
You said the correct answer just a couple of seconds earlier.
Yeah.
Right. You should canon your answer.
Hey.
Go further backwards in time.
Is there a negative sign?
Yes, of course there is. Actually, yeah, I put a negative sign. Here comes the all-time frequent. 0, 20. Then you have log Ri upon Rf equals to 2kt upon m, and time is equals to m upon 2k log Ri upon Rf. So if your radius, say for example, is equals to 2 times of the radius of the Earth, your Ri should be the radius final, and this is initial, and then say for example, if it is 2 times the radius of the Earth, you're going to have 2k log 2. See how beautiful this is? Does this make sense? The bigger the mass of the satellite, the longer it takes to crash into Earth. does, because the bigger the mass of the satellite, the lesser the effect of the force will be on the satellite. Right? Imagine if you try to push a truck versus you try to push a car, versus you try to push a motorbike versus you try to push a bicycle. The effect on the bicycle is going to be more than the effect on the truck. So the bigger the mass, the smaller the effect the air friction will have on the satellite. Therefore, it takes a longer time. Sorry? Inertia, yes, definitely. How about K? If you take a look at K, the smaller the K, the smaller the dependence of drag force on velocity. So therefore, it takes a longer time as well. Yes.
So sorry, I'm just slow. The non-RI, you get it from what? Integrating the non.
Integrated, yeah.
Or the non-RI minus non-RI.
It's RF over RI, but because of the negative sign. No, even.
Oh, I see.
It's flipped around because of negative.
That's nice.
Okay, so something for you to talk about, think about when I'm out there fighting for a better food stall for you.
No. No.
Engineering food, finally.
Really?
Oh, why really?
Can they have impossible?
Sorry?
Like, will they have the impossible meat?
I'm trying to bring in healthy options and salad and food. Impossible burger probably, but it's going to be expensive. So I'm not sure whether it's suitable to be brought in.
Oh, so I'm going to get stuck.
If we go to the case where we have a food stall where it's only for the haves, and the have-nots in the society cannot die, you know that will be a major thing. Imagine people snapshot the menu and then it's all that over $10 and then that will be a good Straits Times material or Kiasu Parents or some material. Okay, I mentioned capital here. I mentioned about the Kepler's second law that the rate of area swept, the dA dt is a constant, is a direct statement that the angular momentum is conserved. So these two statements are the same. When I'm awake, just give me a minute. When I'm awake, try to program. It is within your abilities. I think.
Very easy. What's the RI equals to 2R?
Well, I'm just saying that if you have a satellite that's orbiting at a radius of twice the Earth radius, just for example. So if it is 3 times the Earth radius, then it will be 3 up. So if it is k times it, just k. Okay? I'll be back in a short while. Even though I'm not around, but I can still see you through the CCTV. So
Oh, yeah.
Please behave. Alright, there's an app over here. Watch your students app.com.
Yeah.
Oh.
Bye, sir.